Abstract data type. Abstract data type or class for object whose behavior is defined by a set of values in operation. Next, it does not organize memory. It's called abstract because it gives order or different views. Abstract data type. The user of the abstract data type does need to know how that data type works. Next, for example, the primitive values like integers, float, char data types only with the knowledge that these data types cooperate and performed without any idea of how they are implemented. List abstract data type. The data is stored in the key sequence that is in a list which has a head nodes structure consisting of the count, pointer, and address of compare function needed to compare that data in list. List abstract data type. Python program to demonstrate creation of list. Creating a list. So gagawa tayo dito ng list. List equals to open bracket to close bracket. Magpiprint tayo dito ng blacklist and print list. So ang magiging output ngayon, blacklist is and open bracket to close bracket.
This is how to create a list of numbers. We have the container list, and enclosed with it are the values 11, 22, and 1. Then print the list of numbers. Next is how to create a list of strings and accessing using index. So here we have a list of strings, namely hash brown, then in, then the word McDonald's, then we print the output hash brown in McDonald's. Stack abstract data type. A stack is a linear data structure that stores items in a last in first out basis or LIFO or in first in last out manner. In stack, a new element is added at one end and an element is removed from that end only. The insert and delete operations are often called push and pop. So the functions associated with stack are empty, open and close parentheses, returns whether the stack is empty, size, open and close parentheses, returns the size of the stack, and top, open and close parentheses, returns a reference to the topmost element of the stack, then push, open and close parentheses, A, inserts the element A at the top of the stack, pop, open and close parentheses, deletes the topmost element of the stack, and all of their time complexity is big O of 1. There are various ways from which a stack can be implemented in Python. This article covers the implementation of a stack using data structures and modules from the Python library. Stack in Python can be implemented using the following ways: the list, collections.dequeue, and queue, LIFO queue.
Stack abstract data type implementation using list. The Python's built-in data structure list can be used as a stack. Instead of push, append is used to add element to the top of the stack, while pop removes the element in LIFO or last in first out order. Unfortunately, the list has a few shortcomings. The biggest issue is that it can run into speed issues as it grows. The items in the list are stored next to each other in memory. If the stack grows bigger than the block of the memory that currently holds it, then Python needs to do some memory allocations. This can lead to some append calls taking much longer than other ones. Python program to demonstrate stack implementation using list. First, we create a list called stack, and then we'll be using the list method append to place the item in the stack. By calling stack.append string A, stack.append B, and stack.append C, we now have our stack, and print stack to print out the stack. Pop function to pop element from the stack in LIFO or last in first out order. The pop function removes the last item, the list, and returns the value of the element that is removed, which in our case, calling print stack.pop removes the last element of the stack and then printing out the value C. By calling pop again, we'll return the value B, and again, we'll return the value A, until the stack is empty.
So this is our output after stacking initial stack character A, B, and C. Elements popped from stack are C, B, and A. Stack after elements are popped, we have the only opening and the closing bracket. Implementation using queue module. Queue module also has a last in first out queue, which is basically a stack. Data is inserted into queue using the put function, and get takes data out from the queue. So there are various functions available in this module. So we have the max size function. This is the number of items allowed in the queue. Empty, open and close parenthesis function, returns true if the queue is empty, false if otherwise, and full, open and close parenthesis, returns true if there are max size items in the queue. If the queue was initialized with a max size of equals to 0, then full never returns true. So get function, remove and return an item from the queue. If the queue is empty, wait until an item is available. Then the get no wait, return an item if one is immediately available, else raise a queue empty. Put open and close parenthesis item, put an item into the queue. If the queue is full, wait until a free slot is available before adding the item. Then the put underscore no wait, open parenthesis item, close parenthesis, an item into the queue without blocking. Then the queue size, open and close parenthesis function, returns the number of items in the queue. If no free slot is immediately available, raise queue full. So here we are demonstrating stack implementation using queue module, importing last in first out queue and initializing a stack, setting the max size equal to 3 for the last in first out queue, then printing the output, which is 0 since we didn't put anything yet. So here we are pushing element in the stack and putting the values A, B, C and printing them out. Here we are popping element from stack in last in first out order. So we are printing the popped elements, then using the stack.get function, then print if the stack is empty. Our output is true since we haven't added any values yet.